Hi, in this video, we want to take another look at Bayesian networks. So remember, a Bayesian network is a model where potentially from the start, we're treating all variables as both predictor variables and target variables. So now here, we're not so worried about like causality so much as, like the relationship that if I see that ice cream sales go up, I can go, hey, the temperature outside is probably going up also. Now, causality is not something we want to like really grab onto, but think of this more as when I put the connection between two variables, I'm thinking of it more in like a correlation sense. And when I say correlation, I'm not saying the precise statistics version of correlation. I'm saying correlation in a more layman's term version of correlation. So in a graphical model, what we're trying to do is that we're trying to find variables that are connected to each other. They're correlated in the loose sense of the word. So variables are correlated together, and I want to build the best model I can with the fewest connections as possible. All right, and what we're going to do is when there is a connection between two variables, I'm going to put down like a little circle. The little circle represents, that node represents a variable, and over here's another variable. If they're connected, I put a line between them. We do this a bunch of times, and we get something called a graph. All right. Now, what we want to look at today is predetermining which arcs and edges we want to have included. And after the fact, after the model is built, we go, I don't think that arc should be there, or it's missing an arc, or the arc is in the wrong direction. So in that situation, after the model is built, we want to be able to make adjustments to our model because we want to perform as solid as possible. All right, so what we're going to do for this example, we're going to go ahead and use the groceries data set again that has a whole bunch of binary grocery data where a 1 indicates that one or more of that item was purchased. It's from the A rules package. And notice that if you're loading A rules, you've got abbreviate and write are getting overwritten. So that's something to be mindful about. If you use this package, you might have package confusion. You can try to go with it. All right, so we get groceries going, and remember it's in market basket format. When we pull it from the package, that's not a very good package for our goal for today. So I'm going to go ahead, I'm going to first convert it to a matrix with the as function, and then I'm going to convert that matrix to a data frame. Now, for the purpose of this example, I'm only going to focus on the 10 most common, 10 most commonly purchased items. So what this next part of the code does is that this shuffles all the columns so that the most commonly purchased items are on the left, the least common items for purchasing are on the right, and also this part, the part with row sums, sets it up so that the baskets that had the most distinct items are at the top, and the baskets with the fewest distinct items are at the bottom. And the reason why I do that is so that when I look through and start investigating, I kind of keep that in the back of my mind, and I can kind of get a feel for what's going on. It helps me double check to make sure that my model is working well. All right, so, and something I do, I use the make names function to make sure that all of the names are syntactically correct. The big change for this one, for this data set, is that it replaces spaces with a period. So white space, there is no white spaces in the names. And I need that to be syntactically correct within R. Most packages, it's not a big deal for, but for some of the functions, it won't work, the functions won't work right if I have syntactically incorrect names. So I always make a habit of doing this. All right, so now I went ahead and, because I dropped stuff, I went ahead and double checked the ordering, which is, now this, I did the same thing twice. So, I mean, really, if I took the time to write better code, I wouldn't have the redundant step, but it's not that big of a data set, so it doesn't matter. But it's good practice to not have redundant steps. Okay, so now what we do is we go through, and for each column, I'm going to rewrite this so it's a little bit easier to read. All right, so what we're going to do, I'm going to go through each column, and remember that I loaded everything everything is in the format of true, false, logical before this step. And so I've got true if it's in the basket, false if it's not. So first I want to change that to 0 and 1, and then I change the 0 and 1 into a factor. So the be and learn package, it takes either numeric or it takes factors. It does not take ordinal. I think it'll take integer, but it's rather particular about which things you pass to it. And so this step makes sure that everything will be accepted. All right, so now I've got the data into R. I'm really excited. I can't wait to get into this. So now let's go ahead and build some models. All right, so first and foremost, I'm gonna load the be and learn package. And once again, we have some issues with the functions being named in both packages. Now, I'm going to use the hill climber algorithm. I find that this is a fast algorithm and it gives pretty good results. I probably could get a better model if I started playing around with parameters and different model structures, but for the amount of time you put into it, hill climber is a good choice. All right, so what I'm doing here, I'm just taking it as is. I'm dropping my data set straight into hill climber. Whatever I get is what I get. I'm not worrying about any of the arcs at this point. I'm just building it. So let's go ahead and plot it. And something about these plots, I find, so what it will do what GraphViz.plot will do by choice or by default is it will give you a circle. Well, that circle, if I've got words here and it's a perfect circle, then the height of the circle is going to be rather big. And that forces the plot to kind of get warped, that everything has to shrink down because of that extra empty space from the part above. So what we do instead is we put an ellipse that's tight like this. So then the words fit tightly inside the ellipse and I'm not wasting space. And I find that makes much better visualizations of our graphs. Also, something that's very important to notice is that I'm not using the default plot. The default plot function for be and learn, what it does, it just puts them in a circle and then puts an arrow between them. It's mathematically correct, the information is there, but I find that it's harder to interpret. Now, I can see at times that would be a good choice, but specifically for smaller sets or where I don't really have a direction on things. But for us, for now, I find that this is a much better way to go. All right, so let's take a look. All right, now, if you rerun this without the ellipse command, you'll see that these are circles instead of ellipses, and everything's gonna have to be shrunk down. It's gonna be harder to read. But I can see that roles leads to buns. So from a data point of view, it looks like that roles are leading to buying sausages. Now let's think about that. Do you buy sausage to fill your hamburger? Do you buy hot dogs to fill your hot dog buns, or do you buy hot dog buns to hold the hot dogs? The purpose of a hot dog is the sausage, not the bread, right? Okay, so I'm looking at this, I'm going, hey, I don't like that. That's not right. That's incorrect. That is not good. So what I want to do, I want to rebuild my model, but I want to say that sausage leads to rolls and buns. Okay. Also, I want to go ahead and let's just say that I believe that every time people get root vegetables, they're also going to get another vegetable. So, like, for example, when you go and get your potatoes, you're going to go and get carrots also. Now, from this point, if I have like a customer base where I know that people do not buy carrots unless they get potatoes, but sometimes they'll get potatoes without carrots, then I want to put in an arc leading from root vegetables to other vegetables. All right, so what I'm doing in this white list is that I'm making a special data frame where I'm saying I want an arc going from sausage to rolls and buns. I want another arc going from root vegetables to other vegetables. So what I'm going to do, I'm going to pass this to the hill climber function. And what's going to happen is that first R is going to put those arcs in. Then R is going to go through and check the other arcs in the graphical model. Okay, so when I do that, you notice I have whitelist equals whitelist. I'm not very creative on names today. I go ahead and plot it. And you'll notice that some things look very different. You notice I have whole milk at the top. So like whole milk is kind of like, in this model, whole milk is kind of driving everything else. So this model says, if I can get people to buy whole milk, I can get them to buy other stuff. So we want to promote whole milk. Let's look up here. Where was whole milk again? I can't remember. All right, whole milk is like around the middle. Okay, we changed a little bit of the model and the whole thing changed. Graphical models are numerically unstable. So anytime you have a data change that would change a feature of an arc, you can expect the model to change quite a bit. This is something you need to be aware of and prepared for when you go through. It's a good idea to be doing some pretty serious bootstrapping if you're going to be doing this type of model. Why is that? Because bootstrapping will kind of like double check to make sure it works out the way the model ultimately becomes. All right, let's do another one. Let's do one where this time I don't want particular arcs. So for this example, I'm going to say if someone is going to go and buy bottled water, they're not going to buy soda. So you'll see that in my blacklist, I've got bottled water and soda. So what I'm telling R to do is don't even consider the bottled water to soda arc. Don't even consider soda to bottled water. So here I believe that we do not want an arc for bottled water to soda, and we don't want an arc for soda to bottled water. Like don't even look, don't even check. All of the combinations that are listed in the blacklist are just skipped over, and R will never even consider putting them in. And so working with a blacklist or a whitelist can greatly speed up the computations on this. Remember, when I'm dealing with probability models, these can take a long time to fit, long time to learn these models. If I go through and I know beforehand that certain arcs should be there, certain arcs should not, and I put them in, I can greatly speed up the results. Also, I can improve the output overall if I'm making wise decisions. One thing that I've personally had a problem with at work is where subject matter knowledge contradicts the data. And it's specifically with graphical models, it's come up a couple of times. You just gotta have to navigate those waters. Most of the time, it's just easier to, tell them the data says otherwise, but go the way they want to and forget it. That's all you can do. All right, so here is the new model. So here, our only constraint is that soda and water cannot be connected to each other. All right, so where is water? Bottled water is way down here, and soda is over here. So let's take a look let's look at the original. Well, here we had soda pointed to bottled water, and it was pretty much the same graph except for this one spot. This one arc was removed. Bottled water was at the bottom. So yeah, that's not too much of a change. All right, for our next example, we want to tell R to include certain arcs and exclude other arcs. So I'm going to use the same whitelist as before, the same blacklist as before, and I'm going to build the model. So in this situation, I know that I want that vegetable arc that we had previously. I know that we want sausage leading to rolls and buns, and we do not want any arc between soda and bottled water, and that is accounted for here. So now let's take a look at the model. All right, so now we can see that this looks a lot more complicated, right? All right, so something that will happen is that when the Be and Learn package fits a model with arcs, it will never put in any cycles. There will never be any cycles in your model. It's a directed acyclic graph. Acyclic means no cycles. Okay, so what can happen is when I exclude certain arcs, that can make it so that other arcs can come in, because previously they were blocked from inclusion because it would have increased, or it would have created a cycle. So it's something to be mindful of as you work through this, and realize that the model can change quite a bit from a little bit of tinkering. All right, so what do we do? So far, we've only talked about what do we do before the model is built. Let's say I've already got the model, and overall, I'm very satisfied, but I'm not quite satisfied. There's something I don't like. Okay, well, if you think about it, there are 3 types of mistakes that you can have in graphical models. You can have an arc going in the wrong direction. You can be missing an arc, and you can have an arc present that you should not have. Those are the 3 possibilities of a mistake in a graphical model. So, think about this from like a hypothesis testing point of view, that under the hood, as R learns the models, it's actually doing a crap ton of hypothesis testing for us. Well, anytime we're making a decision, we can make a mistake, right? All right, so of the 3 possible mistakes, wrong direction, missing arc, and having an arc that shouldn't be there, wrong direction is going to be the most common one. Why is that? Well, that's because if you think about Bayes' theorem, conditional probabilities, conditional probability of A given B is proportional to the conditional probability of B given A. All right, they're both proportional to the intersection of A and B. All right, because of that proportional relationship to the probability of A given B, because of that, we can, if there's a little bit of fluctuation in the data, we can get it so that it points in the opposite direction. So one thing that we might want to do is double check and go, hey, is this in the right direction? And we use the choose direction function for that. One time I was in I was having trouble getting a model that was satisfactory using this. And what I ended up doing, and this ended up being a pretty good model, I went through and I built a whole bunch of models, and I went through and I got all of the arcs, all of the edges, and then I created a list that everything that was not in that list was basically like a candidate arc. So I created a huge blacklist from everything else, ran the models, but I did not let R pick the direction like normal. I used the choose direction one to double check afterwards. And it ended up being a pretty good model. There were some difficulties with that in particular project, but the choose direction function ended up being my saving grace for me to be able to complete the project. So here, let's say that I want to double check the arc going from soda to shopping bags. I'm like, is that right? Should it be shopping bags to soda? I don't know, maybe not. So let's go ahead and let's run it. So here, before we run this, we say soda leads to shopping bags. And I run it, and it doesn't change. So it didn't change its decision. That's fine. Sometimes it will, sometimes it won't. Usually it won't change anything. All right, so we can also add an arc that we believe should have been there. So here in this example, we're going to add an arc going from tropical fruit to soda. So, fruit and soda, I don't think they go together. So I threw these in here just because I knew that it wouldn't be part of the model. And so here's the new model with fruit going to soda. So what it does, it just tacks that on, and then the rest of the model pretty much just stays the same. Now, something that's important to realize is that if you have check cycles to true and it would create a cycle, it's not going to add it. It's just going to ignore what you told it to do. If you say check cycles to false, then it's going to add it, whether that creates a cycle, yes or no. So you just be aware of what's going on. If you have a cycle in your model and you try to run several of the functions in the Be and Learn package, it's just going to kick back errors and warning messages and problems. So you really just, if that becomes an issue, you can also just go with edges instead of arcs. Now here we can reverse the direction. So here I see it. I know that it goes, I have it set up for fruit leading to soda. I go, hey, that's in the wrong direction. I know better. I know it should be the other way. So I go ahead and I say check cycles equals false. So now I have soda leading to tropical fruits. Remember, the most common mistake in a Bayesian network will be the incorrect direction. And also we can drop an arc. We can drop it like it's hot. So here I'm telling it to just drop the tropical fruit and the soda arc. And we can see that the connection is gone. All right. All right, that's all I've got for you. I hope you're staying healthy with this COVID-19 business. Take care and let me know if you need help.